All right, looking at number 8 from yesterday's worksheet. X equals, don't like those. They are a pain to graph, pain to figure out. Let's see. I think probably the easiest way to graph the quadratic one is a table of values. Easiest way to graph the one that's not the quadratic, the linear one, is to just rearrange that and make it y equals negative x. So that's an easy one to graph. Switch up some colors here. So for x equals 2y minus y squared, I think maybe a table of values is the best shot at getting this. I guess we'll just start at 0 and see what we learn. So 0, 0. If I plug in 1, I get 2 minus 1 is 1. Plug in 2 for y. Whoops, I'm doing this. Hold on here. If I plug in 2 for y, then I get, this feels backwards. Plug in 2 for y, I get 0 for x. 0, 2. I think I just found the way this thing is opening. Let's plug in 3 for y and see what happens. So that would be 6 minus 9 would be negative 3. Which lands on the line. So we found our two intersections. I think I know what this graph looks like. That's supposed to be a parabola. So this is one that's backwards. Usually we go from left to right of top minus bottom. This is going to go from bottom to top of right minus left dy. So this is one of the backwards ones. So from bottom to top, actually I'm going to pick dy first because everything has to be in terms of y. Yes?
Okay, so you have to, like, so if you change the x, like the equation to y equals negative x, you don't have to do the same thing for the other one too?
I can't, so the question was, I changed this one to y equals because that makes it easier to graph. But I can't do that for this one. I can't solve it for y. So I'm stuck just doing a table of values. If you could switch it, it would not be a bad idea to switch it, but you can't switch that one.
I just didn't know if you needed to have them in terms of the same thing or not.
You do need to have them in terms of the same thing, but they both need to be in terms of y. So even though we switched it because graphing it is easier, when it comes to plugging it into the integral, we'll want it in terms of, terms of y. So we'll go back to the original. So from bottom to top in y values, it goes from 0 to 3. And the right minus the left one, the right one was the red one, so that's 2y minus y squared. Minus the left one, which was negative y. After that, it's a calculator problem, and you get 4.5. So yeah, that's kind of an ugly one because of the dy. We don't really like the dy. Those are harder, I guess, because we're just not used to them. Other questions? Were they easy? Did you just not do them? Three. Again, the graph of that one is really hard to see especially if you do like a standard window, zoom standard, you can't tell what's going on.
Then which one will be on top?
So you have to zoom in and look carefully to see which one's on top. Let's see, there's the parabola. Here comes the x cubed. So the parabola is the one on top. So you got to look carefully. You can also zoom in a little more here. And you can watch it graph. You know that's the parabola. Here comes x cubed, and so you can see it there. But if you also change, you can change how your calculator graphs. So instead of a line, you can make it a dark line by scrolling over there and pressing enter. And so now y1 will be graphed darker than y2. So if that helps. Some of you guys have the fancy calculators where it's different colors, so that makes it a little easier to see as well if you've got that going on. So we're doing top minus bottoms. This is a dx, left to right, 0 to 1, and we said the x squared was on top. And that's one you could do by hand if you needed to, but we got the calculator, so let the calculator do it. X squared minus x cubed. Or you could even do y1 minus y2 if you wanted to do the y-vars thing. But this is an easy one, so it's probably easier to just type in the integral. 0.083. That seems small, but you look at your graph, you're like, well, that makes sense that it's small. It's just that little bitty sliver of area in there.